Okay, so I think let's start. So we're just on time. So uh, thank you everyone for joining in, and it's an exciting session, and I'm sure there's a lot of things that we can take away from this, and we hope to make this Friday a fruitful one for you, and hopefully a little thought provoking, and it can help with anything that you want to understand from this particular topic. So this time it's slightly different, and we're embarking on a new OPC UA FX WebEx webinar series. And to kickstart this initiative, we have an introductory session that will cover mostly on the future of industrial automation, what it entails, and how things are shaping up, what we hear from the industry, as well as specifically on OPC UA FX and how that fits into this landscape. And and special mention to this whole initiative in terms of how this is coming about. It's in a collaboration with BNR Automation as well as Schneider Electric, financial community on the adaptation of OPC UAFX, the key benefits, what it takes to sort of go about implementing this in your products, what are the benefits for the end customers, and yeah, to sort of foster the sense of community, we want to bring in more people into this. And so I'm Nithin, and I'll be your host and moderator for today's session. And with me, I have our OPC UA accredited expert Chatrapathi, and he will be sharing his information on OPC UA FX specifically, but also in terms of his experience and yeah, so between us, we'll try to cover as much as possible to make this an informative session. And this will run for about 45 minutes, and we'll have enough time for a question and answer session. If anyone has any comments, please do drop them in the comment box, and I'll bring them up along the way. And and yeah, so the objective of this particular session was to cover the key concepts that are currently driving the next phase of industrial automation, and specifically things that overcome interoperability issues, real-time data challenges, and also how OPC UAFX comes in with a transformative impact on enabling secure and seamless communication on the industrial automation front. So, without much ado, I think we'll get started. And and the first point that we'd like to sort of bring up is, of course, around how the future of industrial automation today lies, right? So, in terms of that, so there's a lot of tech talk that is happening currently in the industry in terms of the next wave that is driving digitalization as well as sustainability. But when you holistically look at how things look like or come together, it's there's a sort of implementation curve from an end user perspective, as well as how uh, technology providers have to gear up to this. So I think the if you can share a little more insights on how this transformation is coming about, and how this indirectly sort of comes together with specific benefits for the customers, right? Ultimately, it's the manufacturers who have a say in this. That would really help, I think, bring this together. Yeah, over to you, CP.
Yeah, thank you, Nithin. So, in a more traditional way, the architecture is very much layered and it is rigid. So, in every layer, the instruments and the specific hardware and specific applications, they have a rigidity towards them, and the data flows from field level to the upper levels in a hop by hop or layer manner. And security policies also, again, it changes between each layers and how the data propagates as well. So with all this and all these applications, again exchanging data with different type of standards, different type of protocols. So all of this makes it a very rigid architecture. So the industry is moving towards having a much more flexible and open architecture to accommodate all the new age challenges that are being faced by the end users and the industry, and including the OEMs as well. So, having said that, the key areas to look for is having a software defined infrastructure that can accommodate uh, any quick changes or updates or new features and functionalities to be to adapt to that. And then having a data or rich information centric architecture which can have access to good quality information at any given point of time and at any level, uh, upon which all the different new age applications can be built, and new age challenges and use cases can be solved with this data. And then of course enabling cloud connectivity so that it allows for a very flexible and easy enterprise level operations. And also the whole infrastructure needs to be secure by design, because with this flexible and open communication architecture automatically brings in a lot of security related issues as well. So having an infrastructure which is having a very robust security is vital for this transformation as well. So again, all the different components that would help in getting into this infrastructure needs to be built as well, such as smart instruments and different industrial data hubs and remote sensing and monitoring and controlling applications and so on. So with this transformation, I think a lot of the challenges that are being faced by industry would be resolved. Of course, it also opens up new opportunities for OEMs and other companies to build a value added services and value added applications on top of the data and other information that is available after this or during this transformation. Hello, Nithin.
uh, thing is going about is ultimately it comes down to, let's say, having access to data and the aspects of interoperability. So I think if you can highlight a little more in terms of where do we stand today with interoperability itself, like how is that coming about, so that I think that pretty much underlines how OPC UA FX comes into the picture, right? Like, and before we get into a little more details on OPC UA FX, maybe understanding the evolution of interoperability itself is a good starting point.
Yeah, of course. So from the very beginning, vendors have their own way of doing things. So in terms of their specific instrumentation, their specific IO module, it only talks to their specific controller. Uh, this way, the interoperability is doesn't exist. And if you are buying a specific component or some of the components from a specific vendor, then you are locked in to use the entire system end to end from that specific vendor, and it only works with that. So, in case if any specific component of a system has a better features from a different vendor, then you'll not be able to take advantage of that. In addition to that, if you are trying to build uh, any parallel applications to serve your specific needs, then having access to that data in a in an open and understandable format also is challenging. So that was the case before. And slowly, some of these vendors, whatever the specific communication standard that they have been using, have been making it public and made it available through consortiums, and different companies started being part of these consortiums, maintaining these standards. That's how a lot of these industrial communication protocols have been developed, whether it is Ethernet IP, Profinet, Ethercat, and so on. Uh, so with that, we come to the current stage where the interoperability is much better than it was before. Now, any vendor supporting a specific protocol can have certain degree of interoperability with each other. Uh, so with that, uh, systems supporting a specific protocol, then you have a choice to use other vendors components as well which support the same protocol. So then you can have a little flexibility in coming up with your system. But still, this doesn't provide a full interoperability. Again, you need to have some kind of drivers or protocol translators and other means to achieve a true interoperability when you have systems from different vendors supporting different communication protocols as well. So the OPC UA and its technologies, different technologies that are part of OPCA, they're enabling and further evolving to achieve full interoperability in the industrial space.
Perfect. Thanks, CP. I think this pretty much underlines what we were sort of leading towards, like in terms of why OPC UA FX, where its relevance is. And I think you briefly highlighted in the beginning around the the sort of layered architecture in terms of the hops and all of that
Yeah,
coming about. And I think maybe talking about a little, highlighting a little more on those points would be a little interesting before we get into some technical aspects.
yeah, sure, sure. So, as you can see, again, this is a very layered and standard architecture that is on the left here. So the data exchange happens either within a same layer or between layers with custom protocols, and the data models are again incompatible as well. So each device and system will have its own way of representing the data, and that too, the model itself is again a custom one based on which standard and which protocol or specific application that is being used. Also, when the data is getting propagated, it gets processed, it gets filtered, and everyone who's gathering the data from either the peers or from the devices in the down layer, they get to choose and filter and process and make only that data available for the above layers. So with all this, the quality of data degrades as it propagates through these layers, and most importantly, it loses the context and more vital semantic information. It just becomes a data point and its value uh, kind of system. So it becomes very challenging when you don't have access to quality data in solving different challenges like improving overall equipment efficiency, or if you want to build an end-to-end energy aware and energy conscious system, or if you want to optimize operations at all levels, and any other management level problems and business level problems as well. So, transitioning into a well-connected, secure, and interoperable information network. Okay, so it solves many of these challenges, and OPC UA plays a very key role in this transformation. So OPCA with its rich information model capabilities and different discovery mechanisms and uh, all the different consortiums that have built and designed and standardized information models for specific applications. So with all this, you would be able to build a system uh, which is interoperable to a very high degree. So, in addition to this, the technology itself is very much scalable, meaning you can have OPCA on a very small embedded device with few nodes pushing the data to a very high performance system handling multiple hundreds of thousands of uh, data points at any given point of time. So, and it also have multiple multiple ways to transport and exchange this information. Um, so, with this flexibility and then with this scalability, so it is easy for you to have OPC UA vertically in any of the layers as well, moving away from where the OPCA used to operate in a traditional uh, manner. So again, OPCA has different technologies within it, the client server and then the observe over MQTT and the MQP. These technologies enable building in connected ecosystem in the upper layers, whereas OPC FX is focusing on bringing the same level of connectivity, interoperability, and security, and much more higher performance to the lower levels with controller to device, and device to device connectivity. So with all these different technologies coming in together, you have something which you can use to build a complete connected uh, data network, uh, which doesn't have uh, the limitations or challenges that you have in the traditional architecture.
Perfect. I think just on the same point around OPC UA FX that you mentioned, CP, I think can you, uh, I think you have few points specific
Yeah,
to
yeah,
value-driven outcomes, like in terms of inherently what the technology offers as benefits. Maybe if you can talk about that in a little more detail, that'll help.
yeah, sure, sure. So, with the OPCA client server model, we have all these different features, and using those features, the specific applications that can be um, built and used. Uh, can you go to previous slide, please? Yeah, thank you. So here you can see all the light blue colored ones that are a part of the existing OPCA client server model. And when it comes to OPCA FX, when there are stages in which the OPCA FX is being developed. So the first one was to controller communication. So here we use TSN, which is again a standardized time-sensitive network, which provides deterministic data delivery. And on top of it, we have OPC PubSub technology. It uses very minimalistic binary encoded data messages to exchange between controller to controller. It uses UDP or as well as raw Ethernet frames to do this. And when you combine this efficiency with TSN, you get a very fast and real-time delivery of control messages between controller to controller. So, and OPC UA FX also provides full security because the security is already built into OPC UA standard as a technology, and OPC UA FX as well takes advantage of that existing security infrastructure and then expands or extends it a little more to be part of the FX connection establishment process and other activities as well. So then when you come to controller to device use case, again the pub sub and the determinism of TSN are already there, but it allows us to have and support these additional applications as well, including motion, safety, integrating into IO sensors, and discovery and onboarding related to the initial commissioning of the devices, and to have multiple devices on the same network or within a subsystem, and then to have a direct IT/OT integration as well in a very secured manner. So with all of this, it becomes really flexible, and it's the whole system becomes a strong interoperable system. So you don't have any lock-in with any specific vendors offering, and
Mhm.
because of all the different security features that are part of OPC UA technology from the beginning, and as it extends into the OPC UA FX, the whole technology itself is born secure, and it reduces development costs as this is mainly a uh, software and firmware based approach, and it operates on standard Ethernet technologies. There's no customized specific network related aspects are required. Any specific custom hardware is not required. All the COTS products and standard Ethernet based infrastructure will work. And it also opens up a new stream of services, data driven services for the industrial OEMs to have different condition monitoring applications, or to monitor the overall process efficiency and do process monitoring, and so on. And with the combination of PubSub or Ethernet with TSN, it delivers a very high performance as well.
Great. I think so. You detailed about these advantages. I think now understanding, let's say, how the use cases come together, like in terms of OPC UFX itself making use of those aspects around, let's say, determinism and security and all those real time aspects. If you can highlight and describe a little more on how this fits in into the larger scheme and
Yeah,
the key use cases, I think that you've mentioned here. Yeah.
yeah, yeah. So here we can see all the different data streams uh, or different data connections that can be exchanged with the OPC UA. So the FLC the OPC FX mainly operates between controller to controller, and then controller to device, and device to device, and all the other OPCA technologies related to PubSub and client server would allow you to integrate the rest of the systems with the field level systems to have a very seamless IT/OT integration from sensor to cloud, and uh, and the whole system from end to end, it has a very robust security features and security technology. And again here also, again it it depends on the improvements that are already happening in the cybersecurity in general, and adopts and uses those evolutions as well to make it up to date and to keep it up to date and to avoid any future threats as well. And with respect to wireless integration, when it comes to either 5G or other wireless technologies, it provides the configuration and other adaptation approaches and layers to have to be able to use any of these wireless technologies as well. So with all of this, it becomes very uh, feature rich and future ready technology. Even some of the cloud infrastructures that are available have built-in OPCA PubSub modules. So, for example, Azure have built-in OPCA PubSub modules with which you can directly subscribe data from any of the controller that has OPCA PubSub in it. So, uh, again, when you look at some of the points that we discussed a little ago, where having a data from sensor to cloud with all the rich information that it has gathered, because it is propagating through OPC UA, and maintaining that information quality and the context throughout the data exchange is vital for solving any new age use cases and challenges. So, having a seamless connectivity even from sensor to the devices and controllers and beyond through a open and interoperable standard makes way or makes path for having such applications and solving different problems. And having OPC UA bring all these features to the field level is vital for this transition from traditional infrastructure to a connected ecosystem. And OPC UA FX plays a key role in bridging this gap.
Perfect. I think, like you mentioned, the standard itself is growing, and like, can you highlight in terms of, let's say, there has been some recent progress, but the standard itself is maybe a couple of years old, and a lot of leading OEMs have already uh, rolled out products on this space, and they've highlighted use cases, and just to understand for the audience in terms of where we are today and what are some of the key developments that are happening, have happened, especially in the last year or so, and where do we see the next set of products coming out into the market and how you should be ready. So if you can briefly touch upon this, that would be great.
Yes, Nithin, sure. So, in February 2024, controller to controller interoperability plug fest has happened. So, uh, different participants from Rockwell, Siemens, Beckhoff, Mitsubishi, Schneider Electric, Bosch, Rexroth, they all have uh, come to this plug fest with their own implementations of OPC UA FX controllers, and did the interoperability testing between controller to controller communications, and it was that itself was a really big milestone. There were several demos as well that were built and demonstrated prior to this plug fest, but having a plug fest where multiple vendors with their own controller implementations coming to coming together and testing with each other, uh, that provides a very clear picture of how committed all the vendors and OPC Foundation in making this technology uh, to have it adopted widely. And in April, um, OPC FX controller to device activities has happened. Here again, different working groups with large member companies, more than 260 member companies are participating, and several companies have confirmed their participation as well into this controller to device workshop as well. And in July, uh, there is this standard TSM based standard already on IEEE standard that is already there for standard network, nothing specific to industrial. But then the profile on how a TSN specific network infrastructure can be adapted and used for industrial automation. So from that perspective, the TSN profile has been standardized for the use of it in the industrial automation space, and that automatically becomes the basis for OPCA FX TSN profile as well. And in 2024 November, the controller to controller compliance testing program and for the vendors to test their own implementation, a compliance test tool also will be available. And again, in 2025, the goal is to have certified C2C products available in the market, and then by 2026, controller to device portfolio as well to be available in the market, with some OEMs having their products supporting a controller to device as well.
Interesting. So I think there is a lot of movement that is happening, but also in terms of, I think, the drive from OPC Foundation in terms of being making this a little more accessible for all OEMs to sort of understand, as well as end customers to sort of have a feel of how things come together for such a technology is very important, right? And that's where can you talk to us a little more on the specifics of what is available for us, for OEMs as well as users to see, and how different vendors already have products that are placed
Yeah,
in an interoperability setup.
yeah, yeah. Yeah, so from the technology perspective, it is very clear that it is a very open technology. The entire specification is available as soon as it is released on the OPCA Foundation for anybody to access and look at it and use it. Uh, Similarly, all the different member companies that are part of the specification working groups and prototyping working groups have been investing heavily in designing and developing products to adopt this technology and demonstrate their own capabilities with this technology. So one such initiative was to build a multi-vendor end-to-end demo wall where
Mhm.
different controllers from multiple vendors, and then the infrastructure components from multiple vendors, and as well as the configuration and control software from multiple vendors come together and demonstrate a complete end-to-end interoperability has become a very important aspect of this whole initiative. And on the screen, that's what we are seeing. This is a live demo wall that has been part of different trade shows at OPC Foundation booth. So where controllers from multiple vendors are being configured to be part of a single um, bottling plant operation was the use case, and it has been demonstrated, and it is in working condition. And most of the new controller prototypes from all these vendors support OPC UA FX already, and they're prepping for getting them certified and to release into the market as well. Yeah.
Perfect. Thanks. So I think I have one final important point, like in terms of uh, how does this whole thing come together from, let's say, an implementation standpoint for an OEM, as well as for, let's say, someone like a machine builder who is putting together solutions for an end customer, right? Like in terms of uh, the often the dilemma with any new technology is two things, right? Like one is, if I have something, why change? And then okay, when I'm building something new, what do I select? So there's an aspect of uh, the greenfield and brownfield situation that comes about when, and how does that associate with something like OPC UFX here, like in terms of uh, where do you, how do you see that being perceived, or even, like, let's say, how do you face these kind of situations?
Yeah, yeah. So, as you already know, a lot of vendors are moving towards software centric and software driven applications, and the technology is not rigid where you have to say like, oh yeah, everything needs to be OPC FX on day one. So there is no such rigidity to the technology. It is very flexible. So uh, step by step, gradually you can implement, whether you may be a OEM or end user who are trying to adapt to OPC technologies. Very gradually and step by step, you can always adapt. Uh, so the initial step was, even the development of the technology itself was done in such a way that it clearly demonstrates that it is possible to adopt the technology in a step-by-step way. So the initial step can be controllers, and then from controllers to the above level applications having the OPC connectivity, and then the next step can be controller to controller, and then followed by controller to device. So from OEM perspective, depending on how uh, their platforms and product development platforms are structured, it only a software update at their firmware level. Uh, and then if any new products are being developed, those can be designed with OPC FX directly as well. From the end user adaptation point of view as well, it is same. So uh, you can choose to replace gradually as and when things are becoming tight for them based on the use case and based on specific problems that they are trying to solve. They can adapt this technology step by step.
Perfect. I think we pretty much covered what we wanted to, CP. I think in terms of uh, understanding how OPCUA fits in, OPCUA FX specifically fits into the larger scheme of things, and with a lot of those aspects around, let's say, the future of industrial automation itself, in terms of how uh, the different aspects of software defined architectures, as well as secure by design and cloud enabled things that are coming about. And and I think this really was was to coming together of a lot of these things, right? Like, and that's where the objective for today was to understand where we stand, and and let me see if I have some questions. If not, I think I can sort of highlight some points before we conclude. So no specific questions anyway. So the comments are open. So anyone having questions later on can still put them up, and we'll answer it anytime for you. So so this was part one, right? So again, this is a series of sessions that are planned, like in terms of getting a little more deep into this technology and understanding uh, this from different perspectives. Let's say from an OEM perspective, uh, from a machine builder perspective, or even from an end customer perspective, and how uh, this is shaping up. And the larger goal is to sort of educate the community in this space, and there's a lot of material already available in in the web, but we just want to sort of use this forum to sort of spread the word, right? Like, I think so this was a short introductory session to sort of line up this particular webinar series. And thank you, CP, for being part of this, and sort of giving your inputs, and highlighting these points that I specifically brought up. And again, just to sort of summarize, this is a series where you will, every 2 weeks, you will have uh, a speaker come in and bring a new perspective on a specific topic. And currently, this is a joint collaboration initiative with BNR Automation as well as Schneider Electric. And we would welcome other leading industrial OEMs to join us as we sort of go about embarking on this journey around OPC UA FX and educating the industrial community on adapting OPC UA FX itself, right? And I think this was a quick short session, and we will see you soon in a couple of weeks, which will specifically go into the topic of implementing OPC UFX into, let's say, a machine, and following which we'll get into a little more specific on the network side, where it's about defragmenting the industrial networks and how that sort of plays a role in this whole thing, right? Like, and thank you for joining us, and I hope this was worth the time for you. And there are some takeaways, and if you have any questions, do let us know. And keen to sort of see you guys pretty soon, and get this going. Thank you. Thanks, everyone.